Did I share the yesterday's recording? I don't know that. Maybe I need to confirm. Okay. Now I would like us to start from here. What's happening with my device? It's a bit slow. Slow in sharing. Okay, let me know. Is it now visible? Okay, fine. That's okay. Now, remember yesterday we were working on what? We were working on DHCP configuration, and to be specific, we were configuring a relay. We are configuring a relay. I noticed that within the DHCP server here, under services here, then DHCP, you know, what we had put here, okay, was not corresponding to the addresses of where the PC, the other PC, or the other LAN, or the other network for 192.168. Okay, which is that this one here, this one. Okay, so remember we were to add a pool of this LAN or subnet of 192.168.1.0. So our start IP address, our default router, our DNS server, all those, is what we're supposed to have here. That's how simple it was. Huh? So meaning we have created a pool for this. And if at all, assuming you have another interface here, connecting another pool, okay, we call it pool 2 because this was your pool 1, for example. So assuming you are adding another switch and some PCs on G0001 or G002, then it means you'll have to create another pool. Okay, you save this one, then you create another pool and you add. Okay, so you can now have several pools, okay, within your server that will supply now different pools, different branches with the IP addresses. So I want to believe now it's clear. Sorry for that. That's the starting point, is our icebreaker for today's session. So I want to believe everyone now is okay with that. Did you try it yourself? So if you did not, so you can now try it yourself. Right? You find that now with a relay configured. Don't forget to configure relay the way we did that. Don't forget to configure your relay. Enable, then show run. Okay. Yes, we had set a relay. Don't forget on one of the interface, the G00 interface. But the relay IP address is the IP address of the server, not necessarily from that network. It is the one for the server. This one here, which we had given 192.168.2.3. that becomes the IP alpha address for that, which you must set on the interface G000 here, G000. So that one actually remains the same, nothing changes there. Yeah, I think basically those are things that we had set. There was nothing much out there. So that's how, a relay will be able to perform its function. I think that's all I wanted to explain. Let's now start our today's session. So today let us look at the IP static routing. Okay, that is the routing concept that we have. So we have IP static or static routing and dynamic routing. So most of the work for dynamic routing will be covered in the next level, CCNA 3. Okay, CCNA 3. But now in CCNA 2, we're just looking at static routing, where actually you're supposed to add it manually. So even though, yes, you can set dynamic, but static is still being recommended. You cannot have your entire network being set up with dynamic. If I told you want to link yourself to the ISP with one particular route, okay, then static still will be required there. So that's basically what we'll be looking at. So all about static routing, its configurations and different types of static routing that we have. So as you can see, yes, we have different types of static route, okay, that you can configure on a network, whether it's IP version 4 or IP version 6. So all of them, 4 and 6, should support this type of static: standard static route, default static route, floating static route, summary static route. All of them will be set. Okay. So static route are configured using IP route for the case of IP4 or IPv6 route for the case of IPv6 on a global mode. When actually setting up this route, then those are the commands that will be required there. Now, with static route, we have what I'm calling next hop. And we have various options for this next hop when setting the next hop. So you must specify, okay, either the IP address or the exit interface, or you can have both. For the case of the IP address, it's what I'm calling next hop route, where only the next hop IP address will be specified via, that's the point. I'm going to, let's say, to Rwanda via Uganda, okay. Then you can also set the directly connected static route where only the exit interface will be required. So that means you're not going to use the IP address of that particular interface. Or you can do what I call fully specified, where both IP address and exit interface will be used. So these are the three main types of next hop options that you can set whenever configuring a static route. So IPv4 static route are configured using the following global command. We have IP route. Then now with a network. Remember, this network is not your network. It's not the network within your routing table. No. It's a network on a remote, side. So you want to map it, or you want to bring it to your own routing table. So it's going to be network address together with its subnet mask. Then now the next hop the next top options, so there are three that you can set. You cannot have all of them, it's just one at a time. So you have the IP address or the exit interface together with the IP address, okay, or the exit interface alone. As the three options that you will set are there. So you can set IP address, yes, or exit interface, or IP address and the exit interface. Those are things that you can set. Same applies with the IPv6. So this distance that I'm forgetting here. Distance, okay. Now the distance in this case refers to the default number. Static default root is always one. Is always one. Okay, that's the default. But you can have 2, 3, 4. If you want to, create what I'm calling a backup, interface, then this distance will play a major role for you. In the case of IPv6, okay, same thing. Okay, it's just IPv6 root, IPv6 prefix, then prefix length. Now with IPv6 address, exit interface, okay, and or both. Okay, so that's really what you need to consider there. So look at this topology of yours. It's what I'm calling a dual stack, meaning both IPv4 and IPv6 have been configured. Both 4 and 6 have been configured. So currently, no static routes are configured for either IPv4 or 6. Okay, it's just the way it is. So what's the point here? Do you know when these routers are booting up, each of those routers, there are those networks that it will be able to, detect automatically. Like R1 will be able to know there is IPv4 and IPv6 address on the interface G000, or on the serial interface, okay, there. Okay. So you can have both IPv4 and IPv6 because these interfaces are directly attached to it. So that means automatically it will be able to take or to detect this. Same applies. Oh, I didn't start the recording. No, the recording is on. Oh, sorry, sorry for the reminder. The recording is on. Sorry for that. Then, again, sorry. If you look at R2, okay, first let's analyze the R1. R1, so there are two directly attached network, meaning there are two interfaces, a serial interface and an Ethernet interface. Those will serve as the what? A directly connected network. But now the rest of the networks, if you're not attached to R1 directly, then you become a remote. The likes of remote are 172.16.1.0 up here, together with its IPv6 address, okay, 192.168.1.0, okay, a serial between R2 and R3, together with its IPv6 address, or 192.168.2.0, okay, together with its what? IPv6 address. So these are the address that we don't have on R1. So when PC1 want to communicate with PC2 or PC3, it will not be possible because those networks are far away. They're not part of us. And that's why we need to bring them to each of those routers. Okay. Now, let me ask you, if I may ask you, R2, which are the networks which are directly attached on R2? Network attached to R2, directly attached. How many are attached? You have to summarize that. How many are attached? How many networks? Are we together, guys? How many networks are attached of R2? R2. Hello, guys. Are you there? Please confirm. Okay, thank you, Alphonse. At least the responding is now coming in. Can see Alphonse saying 1. How about the rest? I think the rest have left. Wesley, the Cornelius, can see saying 1. Now, there are 0, about 1. There are three networks attached on R2. Okay. How many cables are connecting R2? There are 2 serial interfaces from R1 to R2 and R3 to R2. There are 2 serial interfaces, and there's 1 Ethernet interface. Remember, these are networks. Network. Because each port of a router represents a different network. So there are 3 networks. Is it clear now? Is it clear? Is it now clear? Okay. How about R3? How many directly connected networks? How about R3? Correct. Now it's flowing. Correct. Okay. Okay. We are through with directly connected networks. Let's move back to remote network, back to R1. On R1, how many are remote networks on R1? R1. So you know what I meant by remote networks. How many are remote networks? How many are remote networks as per the table? And anything which is not attached to R1, anything which is not attached to R1 becomes remote. Yes, no, but I can see yes, no, but. I can see Kevin. Mugor. I can see, okay. Anything that is not attached to R1 becomes remote. Now, nobody has said there are 3, which is true. Yes, Jonas. True, there are 3. Remember, 172.168.10 is connected to R2, not R1. So it cannot be directly connected. So in that case, it is remote. Now, on R2 and R3, we have 192.168.1.0. This one, this serial is connecting R2 and R3. It is not attached to R1. This one here, serial 011, is not attached to R1. So it becomes remote. Then the last one is 192.168.2.0 down here. This cable is not directly attached to R1, so it becomes remote. So while on R1, you have 2 directly connected networks and 3 remote networks. Is it clear now? Yes. I want to believe now it's clear. Okay. Now let's now look at R2. While on R2, which are remote networks? How many are able to see? How many are able to see? On R2, Andrew, 2, 7, 2. Yes, there are 2. Correct. There are 2. There are 2. The LAN of R1, that is 172.16.3.0, and the LAN of R3, 192.16.2.0. They're not directly attached to R2. Okay. How about while on R3? Now it's flowing. How about on R3? How many are remote for you? How many are remote for you? Yes, Lesaman. Yes, yes, Kevin. Jonas. Okay, correct. There are 3. Which are these 3? The LAN for R2, 172.16.1.0. The link between R1 and R2, 172.16.2.0. And the other one for R3, 172.16.3.0. Those are remote. Those are remote. Okay. So those remotes are the one that will be required to be configured using the IP route for the case of IPv4 and IPv6 route for the case of IPv6. Those are the major ones that we have now. And you see what we have within our routing table. Because ideally, in a real life situation, you'll not be able to identify which are these, unless now you confirm through commands. So as you can see on R1, we have directly connected networks. Remember they said there are no remote setup or no static yet configured. Okay, so we have the one which are directly attached on R1, which you have seen, the 2 networks, 172.16.2.0, 172.16.3.0. Those are directly attached to it. Okay, they are directly attached to it. So you can ping 2.2 and 2.1. Where is that? While on R1, you can ping this one, 2.2, this port here, and also 2.1, because they're directly attached. I'm directly attached to you. So it means I can get you, you can get me. Okay, are there. Now, if you move to, you can see, for the case of IPv6, it's just the same thing, are there. Okay, so we have talked about next hop. We have talked about next hop IP address. Next hop IP address. So, what is the purpose of configuring the next hop static address? Okay. Now, so in a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. Example, 3 next hop IP static route are configured on R1 using the IP address of the next hop. Meaning next hop means next router. Next router. If I can take you back to the diagram, yeah. If I can take you back to the diagram, I want to leave. I'm on R1. I want to go to PC2 to PC3, including the interface between R2 and R3. Okay, R2 and R3, and I'm on R1. So which is the next router on R1? Which is the next router? while on R1, correct, R2. That R2 is your next top device. Next, underline the word next. Okay, underline the word next. Because there's no link connecting R1 and R3, that one has been left with a purpose. With a purpose. Not that you cannot configure it, it can be configured, but you want it to go there. Okay, so we'll take the IP address of the serial 010 connecting R2 to be the next top IP address. If you want to use the next top IP address, or you can take serial 010 for the exit interface, or you can take both. The serial interface and its IP address can be used. Now, how about R2? Now, R2 is connecting different routers, R1 and R3, meaning next stop won't be the same depending on the device that you are targeting. So while on R2 and you want to move to PC3, so your next stop will be R3. While on R2 and your target is PC1, the next stop will be R1. You are on R3 and you want to move to PC2 and PC1. The next stop IP address now will be R2 interface there. That will serve you. There. So that's the point. So for us to configure this static route, guys, as we have said, so meaning we are bringing in what you don't have. You are bringing in what you don't have. The one that you have are directly attached, like what you already have stated, but static are not there. So you bring them in through this command. And as we can see, if you look at the last part, 172.16.2.2, is the next top IP address for serial interface of R2, because that's the only way out to that R2 or to other network, or when getting out of your network. And that's why now you need to bring in the three networks. Apart from the directly attached network, you have to bring in the directly attached network. So same thing also with 192.168.10 and 2.0. All of them now becomes the remote networks. But now you can see all of them, because you are moving to a specific direction, all of them will be sharing the next stop IP address there, because that's the exit to another network. So same applies also with IPv6, except that with IPv6, you must enable the routing. But that one is a must, using unicast routing. Then from there, it will be able to ping each other. Now, you can have directly connected static route. So with directly connected, now you replace the IP address with the serial interfaces. Previously, you have been setting up this. Okay, this. But now you want to replace them with the interface. That's what you're calling directly connected static route. Okay, for both IPv4 and IPv6. Now, for fully specified, so both will be used. The exit interface and the IP address. So we have at Ethernet 001, then you can see the IP address. Okay, its own IP address. So both exit interface and the IP address will be considered here, will be considered. And that's actually what we have there. So we call it a fully specified static route, where both the exit interface and the next hop IP address are specified. This form of static route is used when the exit interface is a multi-access interface. So that's the point there. That's the point there. Okay, so you can see another good example for this being specified. So again, it is a fully specified, as you can see, the exit interface and the link local address being used. What is the order? The order is the exit interface, then IP address, the way you have been doing configuration. You cannot just say you want IP address without knowing where you are configuring that IP address. So that's really what we have. So interface, then the IP address. In our case, it's FE80::2 being used as the IP address for this. So for verification, you can use the command show IP route static, show IP route network, show running config section IP route, just to confirm your configurations. So it depends with the version of the address that you have are there. Now, for the default gateway, default static route, we have the default static route. I know we have used default gateway so much, but also you can set a default static route. Very, very important. So a default static route matches all packets. So remember on your network, other than the networks that you are receiving, you see, this is as a result of, okay, the configurations that you have done. But when you set default static route, it means it will go beyond what you have set and bring in for you a packet whose network is not within your routing table through static. So routers commonly use default routes that are either configured locally or learned from another router. So the default route is used as the gateway of last resort. It becomes the gateway of last resort. If the default route is not configured, then that is it. You will not be routed within the network there. So that's actually what I wanted you to take note of. So you can see R1 and R2. Yeah, stub router. So that's the point. So gateway of last resort is your only way out. Now, the command for setting up a default static route for both IP4 and IP6 is here. While on a global mode, just specify IP route 0.0.0.0 space 0000. Then, of course, don't forget the what next up options that we have. So this depends with you. Do you want to set the IP address, or do you want to set the exit interface, or do you want to set both? That depends with you. For the case of IPv6, it is : prefix 8. IPv6 root : prefix 0. Okay. Then now with the IP address, for the next stop that you have talked about there. So example is what you can see. This actually you set them up. So meaning with static route set, you can ping anywhere within your network, because if at all the IP address you're trying to ping is not available, the request will be taken out with data are there. So this is actually what we have. So you want to verify whether you have configured a default static route? Yes. you simply, use the command show root static, and you find that, yes, this candidate default root. Okay. Now the other type of static route that we have is called floating static route. Why is this route important? It is important because it serves as a backup route, especially if the primary route fail. Okay, that's why it is important. So another type of static is floating static route. Okay, they're being used to provide backup to primary static or dynamic route. And again, it's only used when the primary route is not available. You see, the route that you had set, is not available. Maybe it's down, okay? So in that case, the backup now will assist us. The backup will assist in that case. Remember what you have talked about. You have said static route do have a default of 1 as its AD, administrative distance, 1, right? 1. But now when you want to make a backup route, so you simply need to increase its number. Instead of 1, put 2, put 3, put 5, put 10, any number in between are there will be accepted. Okay. So we're trying to make that route become undesirable. Undesirable are there. So this can be increased to make the route less desirable than that of another static route or a route learned through dynamic routing protocols. So in that case, it floats. By the way, you can configure several of them, including the floating static route. But when you verify show run config or show IP route command static being used, the one that you set as floating static route won't be available until you remove the other one. Then automatically it will be added as long as you had configured it. Okay, so this is a good example on how you can set the default floating static route. You can see, look at the numbers 2 and 5. 5 the number here. And if you set it to 5, so it means the route won't be what? Available. Okay. If you don't, if you don't set it, so that means that route has not been set. But if you have 5 on it or being set, it's available, but it's floating. It's floating somewhere. It is floating somewhere. Okay, so you can verify that. So you can see by default, the AD is supposed to be 1, as you have seen within this output here. It's 1/0. Okay, but when configuring a backup and you are increasing the number, then you can see it might change. Okay, that's the point there. So how about host root? Configure static host routes. Now, sometimes, guys, you might find that the server. Okay, let's talk of the server. You want to bring in the server of the ISP into your router through configurations. Yes, it's possible. It's possible to bring in the server of your ISP to be within your internal router. It's possible. So a host route is an IPv4 with a 32-bit mask or IPv6 with a 128-bit mask. It's called a host root. So the following are ways a host root can be added to the routing table. Automatically installed when an IP address is configured on the router. Yes, that's one way. Or configured as static, okay, host root. Yes, you can well set it. Or host root automatically obtained through other methods, and those methods are not covered here in the CCNA. Okay, but those are some ways you can actually have the default, the host root being set. So when it is automatically added or installed within the table, okay, so it becomes now a local host when it's automatically installed, okay, it becomes, or it is known as a local host. That's the beauty about that. Then again, take the note of the symbol. With the local roots, all those which have been created automatically, the symbol is L. I hope you have seen L within your output. There's no way you had specified, but you see, automatically, it's being created out of that. This word will enable the communication within the same subnets, not the network. Because C usually is just the network, indicate the network of the interface. But what is now driving this communication is the interface of that particular router. That one is what will be considered as laying local address. So let's look at how you can set up this. So this is, of course, this is ISP side, server and ISP. So we are intending to bring in this IP address of the server into our branch router. We want to bring it inside here so that you can just have it locally within our within our branch router. Okay, so that's what they're trying to explain. So in that case, okay, a host root can be manually configured, static route, to direct traffic to a specific destination device. Okay, so therefore, the destination IP address with a broadcast, guys, not a subnet mask, with a broadcast will be required. Okay. For the case of IPv6, then the entire 128 will be used there. So how do you set it? It's very simple. On your branch router, just have IP root, the IP address of this server, this one here. Okay, together with its subnet mask. What is the subnet mask for this? These are 3 bits borrowed, 27. So it means it's 255.255.255.224. 255.255.224. Because it is prefix 27. That's actually what, sorry, I'm misleading you. It's supposed to be the entire things, prefix 32 bits, not 27 bits are there. Okay, so that's actually what you're going to have. And see 255.255.255.255. Okay, then with the next top IP address here, so I'm on the branch router. What's my next top IP address? What is my next top IP address here? My next top IP address can't be my own, interface IP address. It has to be the next, as the name suggests. So which one is going to be the next top IP address? One of the branch. For the case of IPv4. Yes, for the case of IPv4, which one is going to be the next top IP address? 198.51.100. Dot 198.51.100. 2, correct, Felix, dot 2. Because now you are pointing ISP. Because that server is connected to the what? To the ISP router. And that's why you are pointing ISP. So that that request will be taken from the branch to the ISP, and ISP will command the server to behave, okay, because it's a request coming from the branch there. So that's basically what you need to have for both IPv4 and IPv6, as you can see, are there, okay? So that's that. That's that. Then, so if you confirm, you'll find that yes, it is the host root. It has been added, but as static. Host root added as static there. Okay. So a review of both IPv4 and 6 table verify that the roots are active, as you can see. Okay. All of them being added via for both IPv4 and IPv6 via. I can get to you via next stop via. Okay, that's the point. There. Okay. You can as well set the link local as your next op. Yes, it's possible. You can set the link local as your next op. And in that case, these are fully specified. This one here is a fully specified next op. So we have the serial interface and the link local address being used, FE80::2, being used there. So that's the most important bit that I want you to understand are there. Okay, so that's that. So let's move now to practical bit and see. Let's move to practical bits and see what we can do together. Okay. So okay, let me close the other one. I don't think whether we need it now. I just wanted to show you what you're supposed to do to correct that error. Now that we have done it, I can just close it right away so that I remain with the blank one. So now I'm going to have both IPv4 and IPv6, guys. Meaning, I'm just doing the same topology. Yeah, we have talked about there. I'm doing the same topology we have talked about. So that way, so yeah, so this is the topology that I want us to do. It's a good one. It's a good one. The topology that I want us to do. So we have 172.16.30, 172.16.20. It's 1, 2, 3 from up. Then this 192, 168.1.0, 192.168.2.0. Okay. Yeah, I want us to have this. Then for the case of, okay, there's no problem with IPv6. So long as you have mastered the one for IPv4, IPv6 will just be, will be there automatically. We'll be able actually to set it without any issue there. So I'm going to have a router. Confirm that we are together at that point. Confirm that we are together at that point. Thank you guys for confirming that. Thank you for confirming. So let's now move to router. So I'm going to have 3 routers. Okay, 3 routers. I always prefer doing the configuration from the scratch because this is giving you an opportunity to learn, more about the configuration from the scratch. Even if now you go to the one that you have been given on the portal or through the syntax checker, so you don't have any worry because it's something you can do confidently from the scratch. Then I'll add the switches, the 960 series switch, connection. Okay. Which one have they used? Let me check the kind of interfaces that we have used. Oh, we have used the serial interface, the red one. Those are serial interfaces. So I'm going to add the serial ports on these routers. But meanwhile, PCs, the PCs, there, and finally up here. Okay. Because of spacing, I'll just drop it here, put the switch here, and have, it up here. Still is okay. Still that is okay. Okay. This is a setup that we are doing together. Okay. Very good. Very good. Now, let's now move to Ethernet. So G000 on all routers to G01 on all switches. Okay. G00 to G01 on all switches. So giga and giga goes together there. G000 to G001 on both switches. Yes, as you can see there. Okay. Then the PC's Ethernet port, I can have any port 5. Port 5, but any port can be used, so don't worry. Port 5. Port 5. All of them. Port 5. Okay. Now, so when using the serial, nowadays I know most of those routers come with the Ethernet, ports. Huh? They come with the Ethernet. Nowadays, most of them are coming with the Ethernet port. It's like they are doing away with the serial ports. Huh? If you look at the latest series, remember we bought some. We bought some which were imported. The new series 4331 series. Yeah, that is 4000 series. They did not have the serial port. They had only the Ethernet port. Huh? But now they have increased the number of ports are there to support, all those Ethernet ports that were provided. So the serial the serial DCE and the serial DTE. So let's agree here. Which one is which? Serial DCE. DCE means data communication equipment. When you set a port with a serial, when you set a port with a serial DCE, it means you become the ISP. I hope we're together. For data synchronization, meaning we're going to set the clock rate on the port. We're going to set the clock rate on the port. So it means automatically you become the ISP. But if it's a client, both are client, let's say assuming like ICTA, and you're connecting your routers, you set the serial, then you take the serial DTE, data terminal equipment. So in that case, in a real world kind of situation, it is the ISP who is supposed to set their end with DCE, not you. For you, just get the interface from their end, because already they have set theirs. So they'll have their gadget coming in and plug it within your premises, have it there being connected, okay, to your device. But they have already set their end as the DCE. And that's why now we are getting those, signals coming in. But for these demo purposes, now I'll be using this one. So I've taken, now please take note of this. This one has the clock symbol. And I want to add it here. Okay. So it means that router for that port now is the one that will be synchronizing signal to the other port for the other router. But something else that I want us to note, we don't have the ports for the serial. We don't have the port for the serial, so we need to add them. The only one that is there is USB console, auxiliary console, and gigabit Ethernet. So meaning your serial cable does not have a port where you can insert it. So this is what you're going to do. So escape for that disappear. Then you need to add the serial port. So click on that router. Then under the physical tab up here, okay, let me zoom in for it to be a bit bigger. Then I need to switch off. Before adding it, I need to switch the light. Then which one is the serial interface? Under the modules, you have this one, this module 2T. If you look at its description down here, okay, the NIM 2T is a 2-port multi-protocol synchronized serial. The rest, if you look at the rest, this one's a cover, okay? This one is Ethernet, as you can see. Look at here, down here. Anytime you are pointing any of those, look at the changes here, okay? If I click on this, okay, that's what I have. If I click the next one, that's what I have. Click on this, that's what I have. Click the last one, that's what I have. So I have this 2T, which provide me with a serial port. So I can drag it to the space here, meaning I'm installing it. It's just the normal hardware installation where you just need to add. You just need to add it, okay, that port. Then don't forget to switch on the light, okay? So if you get back to this, you'll find that it has added, just point on it. Can you see below there? It has added the serial 010, 0011, 0020, 0021 has been added. Okay, because each has two, that's why they have 4. So do the same for the rest of the devices. Okay, zoom in, switch off the light, then drag the serial there, drag another serial module, then switch on the light, move the next one. Okay, zoom in, switch off the light, then again, then again, and go back, switch on your light. So always, that's what you do in case you want to use the serial. So you can see all the serials have been added. So I can now go ahead and pick the DCE, then add, can see now have serial. So for consistency, I can decide to use serial 010 being taken to serial 010 for consistency. Okay. Then I have this one again, serial 011 being connected to serial 011. So I've added my serials cable. If you want, you can even add another one here. That will serve as a backup, but there's no need. Let's just leave it for now. Then after that, I have my IP addresses that I'm supposed to have here. I have 192. Sorry, it was 172 as per the topology we had. .16 dot 3.0 that's 24. Okay. Then IPv6 2001 colon DB8 colon ACAG colon 3. Okay. It's just the same network, but IPv6. Then colon prefix 64. Okay, so this is what I have. I'll do the same. Can just copy paste, copy this, move to the middle part here. Okay. Then here I'll put as 2.0 and 2 colon prefix 64, which is the network, remember? Okay. I'll do the same for the upper part here. Copy paste. I'm going to have 1 colon prefix 64. Then I have also 1.0. Okay. I'm going to put the other one here, in between here. I have, sorry. This one, I think we had different classes of address. It was 192, 168, .1.0, prefix 24. Then put here, I'll put, this was 3 colon, this was 2 colon, 1 colon. Let's have this as 4 colon. Then finally, I'm going to put it here. So this is 5. This is 5. Then this, it will be 192. dot 168 dot 2 dot 2 dot 0. Okay, so I've set my addresses, as you can see. So what is remaining is now the configuration. And by the way, you can do the labeling of the port numbers in each network. I want this one, this port here, to be port 1 on this network. So it will be 172.16.3.1 for the case of IPv4, or 20.8:AC/AD:3:1. So I can do the port numbering to make my work easier. So this will be 1. Okay. Now, because this port 1, automatically this becomes port 2 up here. So meaning this will be 2:2.2 or 2:2. Okay. Then up here, it's the only interface. So it is 1.1. Just this port 1 or 1:1 up here. So this will be 1. Okay. Down here again is the only interface. So 2.1, 192.68.2.1.1 here. Okay. Dot 1 here for this. Then in between, we have this one, this serial. So you can have the first one, maybe, depending on your numbering, you can decide to have that as 1. Then below here, you can have this as 2, for just numbering purposes. So when we do your configurations, we know which port is which. Okay, now let's start. So we're going to enable our interfaces for both IPv4 and IPv6 at a go. So move to that router. Okay. Okay, anyway. Akili imeenda mafiongo, nimeona vitu zingine. Config T for user mode. That's serious. Okay, anyway. So config T, then host name, call it R1. Then the interface is G0/0/0. Okay. G0/0/0. Then IP address 172.16.3.1. Hope we are together. This one, 3.1, 3.1, 3:1 for the case of IPv6. So .3.1, then 255.255.255.0. Okay. Then we have IPv6 address. So we have 2001 colon TB8 colon ACAD colon 3 colon 1 prefix 64. Prefix 64. As you can see there. Okay. Then no shut to enable that interface. On the same interface, or rather on the same router, we have the serial interface here. The same serial interface, which was serial 010. So I'll just add it can just add it on this mode, it's no problem. Int serial 0.1.0. Okay. Then serial 0.1.0. Okay. Then in between is 2. So I'll scroll up. So I have 2 dot. I've talked of 2.1. Enter. I've talked of 2 colon 2 colon. Allow me to confirm before putting things that I don't understand. It is, did you mention that it was port 1? This is port 1. Because this is 2, so it is now 2.1 and 2 colon 1. Yes. 2 colon 1. Okay. There. So that's serial. But now don't forget, guys. If you point on this interface, there's a symbol of a clock, meaning that port is a DCE port. It's a DCE port. Because it's a DCE port, you must enable the clock rate. So while there, have your clock rate, and which series, okay, there are quite a number, shift question mark. It will list for you those in terms of speed. 1200, 2400, 48, 96, you know, it's just that doubling those numbers, as you can see. Okay, until you get to 4, is it 4 million? Yes. So based on the agreement, the amount, each amount will have its own speed. Each amount, let's say I'll be paying 1,000 per month. So this is speed. So it depends on the package. I'll be paying 5,000 per month. I have my package. Okay, so package will differ based on what you are paying there. So by default, let's use 64,000. Okay, maybe for someone who's paying 5,000 per month. Okay, because it's being directed to you from the ISP. Okay. Then, yeah, I think that's that. Clock rate was, that's what was remaining. Then no shut. No shut. But it cannot be up if the other one is still down. So they have to be up, all of them. All of them. Then, now we're moving to this. Upper, gonna 3 of them with 1 clock rate. Okay. So this what, okay. So I move to this. Config T, interface G0/0/0. Yes. Okay. Wait. Oh, there's one here, up here. No, in fact, it's 0.1. It is 0.1. Okay, it is 0.1, not C. How comes are not? No, it is 0.0 by the way. Let me remove it and plug it again. Yeah, it was 0.0, sorry. 0.0. Oops. 0.0. Sorry. IP address. I can start from any point anyway, but I'd intended, okay. Let me just wind up with the serial. Let me wind up with the serial 0/1/0. The reason why I'm winding up with this serial because of this serial already that I've configured here. Serial 0/1/0. Because it was 2 colon 2 and 2.2. Let me just wind up with it, then I can move on to something else. Okay, then IP address 172.16 is it .2.2. Okay, don't forget that 255.255.255.0. Then IPv6 address. Okay. There's no copy pasting from the other router. This one here. Also the part of IPv6 copy. Then move, okay, and paste. But we change it is 2::2. Okay. Then no shut. Remember, this is the other side of the clock rate. The other side is the DTE. So clock rate DTE. So I'm just trying to enable that part. So I'm through. Okay. This one. Host name R2. So you can see, you can come back anytime and set what you have forgotten. There's no order. As long as you have configured it, that is it. Okay, so R1 and R2 set. R1, R2 set. So R2, I've done with one interface for the serial. So that's why this serial is up. So I'm now doing the Ethernet interface up there, G00. So interface G0/0/0. Then scroll up, IP address. That one is 1.1. 1.1. Enter. IPv6, scroll up. 1:1. 1:1. Okay. Then no shut. No shut. So I'm done with the LAN of that. This LAN here, up here. Okay, up here. Now, I'm doing now the last serial R2 here, which was 0011. That's what I'd picked. 0011. Now, but note the IP address is 192. 192, not I can see 1. It is 192, not 122, 192, 168. Okay, that one was just labeling. So that's what I'm supposed to have there. Set it. So int serial 011. Then IP address, it is 192. 168. Was it .1.1? Let me just confirm. Here it is, yeah, 1.1. 1.1. Then IPv6 is 4. IPv6 is 4::1. Yes. Just do it once and for all. Okay, enter. Then IPv6 address, copy, paste, 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 paste. Then it is 4 colon 1. But remember, again, this port has a clock rate. So I'll be using the default clock rate. That is 64. 64, 1, 2, 3. Okay. Then no shut. But it will not be up until the other side is up. So I'm through with that part. Then I'll come now and finalize with this part. Okay, then so we have interface G0 stroke 0 no, let me deal with the serial first. 0 stroke 1. Then IP address 192.168.1 no yeah .1.2 then 255.255.255.0 okay then IPv6 address then I'll do paste this I'll do 4 colon what it was 4 colon 2 4 colon 2 other one we had put 4 colon 1 correct so this 4 colon 2 okay are there being set okay being set so 4 okay 4 colon 2 then no shut I'm through with that then finally this 2.1 and 5 colon 1 on that Ethernet interface there. So we have int G0 stroke 0 IP address 192.168.2.1 then 255.255.255.0 then no okay I can do all of them at once IP6 address paste then 5 1 okay then no shut so I'm done with all my interfaces I've done with all my interfaces are up now do show IP route the routing table for the case of router 1 you can see it is you can see here it has 2 directly connected networks so it's time now to bring in the remote networks because if you don't then PC1 the PCs will not be able to communicate for this PC0 let's call it PC this PC3 and this is PC1. For PC1 to be able to communicate with PC3 or PC2, then the networks, all these networks must be configured on R1. And that's why that static IP routing is very, very important. So that's how we do advertise the network, but manually, okay? You are doing it, but manually. So in that case, sorry, in that case, so we have, so we have agreed that what we're going to set here, is the three networks. The three networks up here, here, and here, because we need it to be here. Okay, so we're moving to global mode, exit, then IP route. So the first network is 172.16.1.0 with subnet mask of 255.255.255.0 with the next top IP address. All of us, all of those PCs, whether you want to go to PC2, to PC3, or to the one interface of R2 and R3, your exit interface will be 2. Exit will be 2. So you're going to do 2. Okay, 2.2. 2.2. So you're going to have 172.168.16.2.2. Okay, that's the first one you have added. Then now scroll up and add 192. 192.168.1.0, correct, and .2.0, correct. You must add these two. Okay, on R1. IPv6 route. Okay, IPv6 route. Don't forget you have IPv6. IPv6 1, 4, and 5. 1, 4, and 5. Okay, so IPv6 route paste. Okay, 1. Okay, what is your next top IPv6 address? 2:2. 2:2. Okay, paste. 2:2. Okay, then here this one, remove that one because it's the network we are dealing with. 1: prefix 64. It's the network we are dealing with. IPv6 route. What is it? How comes there's an error? Oh, sorry, you remove this. This 64 is not supposed to be here. Sorry for that. That 64 is not supposed to be there. Then you scroll up. Then you remove this. So it is 1, 4, and 5. That is 4. then 5, then 5. Okay. I'm done with that R1. So I'm moving to R2. I'm moving to R2. Exit. So R2, there are only two, depending on the direction that you have taken. So you have this and this. So the exit interface will not be the same. Please take note of that. Otherwise, the packets will not be communicating. So I need to have 3.0 and 2.1. Okay. So IP root, what I don't have is 172.16.3.0, 255.255.255.0. Okay, .0. Next top IP address will be 172.16.2.1. Okay. Then we have one IPv6 there. One IPv6. Okay. IPv6 root. IPv6 root. Which one is that? It is here. This one, 3:::. 3:::. So it means these two will be taken to R2 up here. That's what we are trying to do. That's the essence of doing all this. So now we have 2:::1. 2:::1. So you are bringing in paste 3. Okay, but you remove this one here. Then next hop, paste. So you remove this. Then you're going to have it was 2:::1. I'm confirming. Yeah, it is here. It is here. 2. Yeah, 2:::1. Yeah, it's okay. Okay. That's the first one. The other one is for this side. It's for this end here. 192.16.2.0 and there 5. Okay. Take note of the column that we have, column 2, 1.2. So first, let's have our network there. Let's have our network. Sorry, we're up here, still up here. Okay. You must have that. So scroll up. So it is 192.168. Okay, what I don't have, 2.0. Okay, just confirming that I have 2.0 here. I'm taking this one up there again. Then 5:::. 5:::. IPs. So 5:::. But before then, it is 1.2. 192. Yeah. .192.168.1.2. 1.2. Okay. Then IPv6 root. IPv6 root. So we have five colon. Then next hop is 4 here. Next hop is 4. You see here 4 colon 2. 4 colon 2. Okay. So that's what you put, remove prefix. So that is 2, then 4. 4 colon 2. 4 colon 2. Okay. Finally, as we wind up, finally, you have this. You have this. Okay. So this one, you can see what we have up here. 172.16.1.0, 2.0, and 3.0 being added. And by the way, this kind of addresses is what I'm calling contiguous addresses. So you can do what I'm calling a root summarization, and you come up with the one subnet that will carry 3 of them. If you don't, the system will do it for you. Okay? The system will do it for you. So it's another process that you need to follow there. But it's a very simple one anyway. Okay, but it's called root summarization. So you summarize because it's from the same class, and it is contiguous, as you can see. Okay, meaning it can be summarized. It can be summarized. So instead of having all those 3, just have one. Due to time, I'll not be able to take you that process. I know it will take some time. So, but let's just do this one as we wind up. So IP root 172.168.16.1.0, 255.255.255.0. Next up IP address. I'm now on this router. I'm now pointing this one, the upper part. So it is 192.168.1.1. Okay. So 192.168.1.1. Okay. The rest, so scroll up 2, enter. Scroll up 3, enter. Then IPv6 root, we have 1, 2, 3 again. 1, 2, 3. So we're going to have it here. Paste. Okay. So we remove this that one. So it is 1. Okay. What is the next top address? It is 4. It is 4 here. It is 4 colon 1. 4 colon 1. Okay. 4 colon 1. So we're going to check on that. So it is 4 colon 1. Okay. Enter. Sorry. I'm supposed to remove this. Supposed to remove the last one. Okay. So again, it is 2 2, then 3, contiguous. Even this one can do root summarization. So you might end up having another summarized root, maybe 2001, DB8, ACAD, colon. Now summarizing the remaining one are there. Okay. Then so that's all. I think we have done all our network. Can just confirm do show IP root. Okay, you can see the network here are added. Okay, via. So which networks are this? If you check, you are on this router. You are on this router, but this, and this are added. So we are good to go. You can confirm the central router. Do show IP root. Yes, you can see, yes, this and this also added. Okay. Then finally, you can check on this. Okay. Show IP root. Yes, also that is added. Finally, show IPv6 root. Also, IPv6 is added. Okay. So all of them, that's how they'll be. If you check, that's how all of them will be created there. So you can come back to your PCs. So you can see this is 3.10. This is 1.10. This one will be 2.10 for the case of IPv4. Then this will be 5.10 for the case of IPv6. This will be 1.10 for the case of 1:10. And this will be 3:10. So let's move that and move to desktop IP configurations. So we have said this will be 172.16.3.10. Okay, but remember to change this one because we have used 255. Okay, yes, you have a default gateway that you need to put, don't forget, which is 3. Okay, 172.16.3.1. Okay. For the case of IPv6, it is 3:10. 3:10. 3:10 is this part of 64 here. Supposed to put, then Control C, Control V. This is 3:1. 3:1. So you're through with that. Move the upper one, 172.16.110. Okay. Here we have 172.16.1.10. Okay, don't forget to change this part. Okay, 255. 255. Don't forget you have the default 172.16.1.1. Okay, you have IPv6 paste. It is 1. It is 110. 110. It is 110. Don't forget you have the default 3:1. Then here is 64, which also you must add. Okay. Okay. So very good. What is that? The problem there. Oh, 64. Did I 64 there? I thought I'd add. Correct. Then here, finally, finally, it is 192.168.2.10 and 5 colon 10 for the case of IPv6. So here it is 192.168.2.10. Okay, masks. Okay, that's okay. Don't forget you have a default gateway dot 2.1. In the case of IPv6, it is 5. It is 5 here. For the case of default gateway, it is 5.1. It is 5.1. That's what you had set on the interface. It is 5.1. Yeah, so you have your addresses, and now this your network is supposed to communicate successfully. So you can now ping just to verify that everything is working correctly, both IPv4 and IPv6. So from 3.10, I can ping 2.10. Okay, here. Command prompt, ping 192.168.2.10. Okay. Let's give it some times before it pick. As long as you have done the right thing, it will be able to communicate there. Oops. Okay. So, very good. So let's troubleshooting start. So where's the mistake? I think there's somewhere. I must have made a mistake. This is 210. 210. Okay. I'm just trying to check where. First, am I able to, let me see. Let's start with your row, no? Let's see whether I can ping, no? Let's see whether I can ping 3. Confirm default gateway. Yes, that's what I want to do. Thank you. That's what I want to see first before going further. So this is 3.10. So am I able to ping 3.1? Let's start from there. Am I able to ping 3.1? Ping 172.16.3.1. Correct. Am I able to ping this one? 2.1, the serial, pointing R2, the serial, pointing R2. Okay, the serial pointing R2. Okay, so it is 2.1. Is it? It's a problem here. I hope I've written the right one. It is supposed to be 172.16.2.1. How comes? Then this is where the problem is. Huh? You see, I cannot move this router. I cannot move out of this router. I'm being blocked on this serial interface here. This is actually where the problem is. Huh? It's not even the issue of network because this is directly attached. So let me check, go back to the serial. Let me check the default gateway here. Hey. Who put this one here? Someone came behind me and put 15 instead of 16. Na ni wewe tu na mwingine. Hii ni 16. Sorry. You see, it was very interesting. I cannot even get out of my own router. Okay, I think that one now we have rectified. We have rectified that. So I believe that's where the problem was. Okay. So let me see now. Can I ping that? Yes, it's okay. Can I go back and ping now? That PC was, yeah, 2.10, no? 2.10. correct. So the problem with the default gateway of my own router, that's why I messed up. Instead of 16, I'd put 15. So if I can reach the other side up to this point, you see there's no problem. Even if you have packets, simulation mode, okay. Have packets from here going all the way to this point, okay. Then play. As the packets are moving. Okay, can see, yeah. So meaning this communication, there's no problem. Yeah, there's no problem. So we have pinged, we have used the packets, and everything is okay. Okay. Finally, guys, you can set the default gateway. You can see it's going back. Can even move back to real-time mode, the command prompt mode. Now, finally, I've talked of the default route. Remember, even you know, you normally receive the emails, not necessarily from your network where you are, even the one from outside, which means that your network has been set with a default route, accepting the packets from outside, so long as it has been directed to you. So default route will be able to direct them. So with the default route, I can set the default route on R1 if I want. Okay, so I can go back, but usually it's being put on the central device, that point, both sides. For example, you can put it on R, this for the central one. So pointing R1 and R3, okay? If you wish, you can, if at all this will be the ISP, so pointing on both sides are there. So you can just now have config T, then IP route 0.0.0.0 space 0.0.0.0 space. Then don't forget guys, don't forget how to call it, the next stop, which is now 2.2. That's what we had set. 2.2 for the case of IPv4 and 2:2 for the case of IPv6. Okay, so we have 172.16.2.2. That's what we had set. Then IPv6 root, okay, colon prefix 0, then paste this. It was toward this one. It was 2:2. Let me just confirm if that's the one. 2, yeah, 2:1, correct. Okay, so you have set the default route on both. So if you go back and confirm show IP route, okay, you'll find that the default route has been added. Now appearing as the gateway of last resort up here. Confirm from the other routers that you have not set with the default route. Confirm with the other routers that you have not set with the default route. Show IP route, okay? You'll find that the gateway of last resort is not set because you have not configured the default route, okay? Do the same for IPv6 because that's what we have configured. Show IPv6 route, okay? You'll find that IPv6 route has been set up here, but usually this one don't give gateway of last resort. Neither the how do you call it? It's a term here. The asterisk. The asterisk. Asterisk only is applicable with IPv4. So this one does not have the asterisk, which indicates the candidate default route. But for the case of IPv4, as we have seen, is a default route here, indicating this is a candidate route for default gateway there being set. Now, the beauty about OSPF, the dynamic routing protocol, is that you can only set the default route on one router. Then the rest you propagate. Is a command is propagate. So they'll be distributed all over, even if there are 20 routers at once. That's the beauty of dynamic OSPF, which now will be covering from next week, CCNA 3, when we'll be introducing CCNA 3, the part of CCNA 3, okay, are there. So that's what we'll start with from next week on Monday, okay, when we'll be doing that. Then, then now, when it's come to the troubleshooting bit of it, allow me just to wind up this because they're just connected. Troubleshoot static, you see like what you have just experienced with my pinging there. You know, we have seen there's a problem, and my problem was the default gateway. So sometimes, yes, you can be experiencing, you know, you're wondering, how comes there's no flow of packets, there's no movement of traffic, you know, where's the problem? So your troubleshooting starts from there. With those commands, there are various commands that you can use. So in my case, I was supposed to use ipconfig. If at all, you know, that was the case for that. So you check each and every device that you have. So you're being told PC1 is addressing to PC3, okay? So when the packets, you can see the movement here. So expecting the flow to move until the end. But in that case, if there's a matching between your addresses, then there'll be no problem. If there's no match, does not match the specific route, then there'll be a problem there. And they'll end up now, packet will end up being dropped, and the source will be notified about that, you know, problem there. It's what they're trying to explain using the now that you have the topology, so at least you can explain as you move on. Okay, so this is just to confirm that packet is moving the way we have seen in our packet. It has moved from PC1 to the last one without any problem until it gets to the end, as you can see. Until it gets to the end, as you can see there. So now let's start our troubleshooting. Sometimes there might be some changes, network changes, which could be as a result of the interface. Okay, the interface has failed, it's faulty. Could be a problem, would be the ISP, not you. That's why troubleshooting is very, very important. Or the interfaces, the link are congested, oversaturated with the traffic. Or it was a problem from you, like me or what you have seen with my topology. There was a misconfiguration problem. It was from me. Okay, so those are things that can cause the network to change. So it is your responsibility to pinpoint all this and solve them. Okay, so to efficiently now do that, okay, so it's always good to have those tools. In this case, for you, the commands that can help you to quickly identify and, you know, sort out all this problem. So the tools or the commands which are available, these are just few of those commands, but there are quite a number, as you know. The likes of ping, trace route, you know, show IP route, show IP interface brief, you know, show CDP neighbors. By the way, who is your neighbor here? Who is your neighbor here? Who is your neighbor here? Okay. Who is your neighbor here? Show CDP neighbor. Okay. with your neighbor. Your neighbor is, I'm on switch 1. My neighbor is this switch, though I'd not renamed that switch. It is, but it is here, this switch. It is this switch. You see, my neighbor is this switch and this router and this router. That's what I'm getting. Okay, these are my neighbors. If you add details, show neighbor details, then they'll give you the IP address of this, R2 IP address which was configured. Had not set the IP address on a switch. Also, that one would have been included. But you can see it giving me, okay, down here. Okay, so I'll get all those details are there based on the neighbors. My neighbor that is there. And now I'm connected to my neighbor. And now I'm connected to my neighbor. Okay, so we normally advise this command to be used for some specific occasion, then you remove it, no CDP, okay? You disable it because the hacker can take advantage of that to understand, oh, here are the neighbors for this person here. So long as he has accessed the network, then he can easily navigate from that R1 to R2 to switch. So those are things that actually we need to understand are there. Okay. Now, in that case, they want us to identify a problem here, but this one you can see, next stop is the problem as per the output. Next stop is the problem. Where are you? I'm on R2. Okay, this R2. So R2, you want move to, let's say PC1, because this R2. Look at the next stop, the one that has been highlighted here. This one is for the other side, not even this side. Okay, so there's a problem. That tells you it's a problem here. So that's why in the exams, most of the exams, but these are things that you'll get, giving you the exhibit like this, then ask you to identify the problem and rectify the problem if engineer Korir wanted to move from, PC2 to PC1 and is not able, okay, help identify where the problem is and, correct the configurations. So you have the exhibit with you there. So have your full eyes on the screen, line by line, to find out where the problem is, because the problem. That's how simple this certification exam, especially if you get this kind of topology, then you don't strain. You'll be moving a bit faster. Theory sometimes a problem, but labs are just sure bet, because that's where the marks are. They have a lot of weight than the other theory bit that sometimes might be a bit challenging. Keep on forgetting are there. Okay, so basically that's how you need to identify all these problems that we have are there. So I just wanted to connect the two because there's nothing much here other than using those commands that are there. So guys, that's all for today's session. I know it was a long session with some configurations, not complex, but it was simple but very wide configurations because we had included both addresses. That's why it looked a bit longer but not complex there. So that's marked the end of CCNA 2. Okay. And next week now we'll pick from CCNA 3 because we need to wind it up as soon as possible because I know there are other programs coming up still on your side that you need to do. So I have to utilize the time that was assigned to me, okay, accordingly. Okay, but in case of any question, guys, let me know. You can still communicate on the group, WhatsApp, or you can call me. So that's all. Unless someone has a question, let me know. If there's none, enjoy your holiday. I know tomorrow is a holiday. Let's meet on Monday there with more configurations or with more sessions, guys. Enjoy the rest of your evening. See you. Bye.